Hey everyone! Today we're tackling a classic interview problem that tests your ability to optimize a search. It's the best time to buy and sell stock problem. It looks simple, but the jump from the naive solution to the optimal one is where most candidates get tripped up. The goal is straightforward. You're given an array of prices where each element is the price of a stock on a given day. You want to maximize your profit by choosing a single day to buy and a different day in the future to sell. For example, if prices are 7, 1, 5, 3, 6, and 4, the best move is buying at 1 and selling at 6, giving us a profit of 5. If the price only goes down, we just return 0 because no profit is possible. The most intuitive way to solve this is the brute force approach. We basically try every single possible pair of buy and sell days. We use a nested loop. The outer loop picks the buy day, and the inner loop checks every subsequent day to see what the profit would be if we sold then. We keep track of the highest profit found so far and update it whenever we find a better deal. It's simple, but as you can imagine, checking every pair is incredibly inefficient. To optimize this, we need to stop thinking about pairs and start thinking about the minimum price seen so far. Instead of nested loops, we use a single pass. We maintain two variables, one for the lowest price we've encountered and one for the maximum profit. As we iterate through the list, if we find a price lower than our current minimum, we update it. Otherwise, we calculate the potential profit by subtracting the minimum price from the current price. If that profit is higher than our record, we save it. This way, we only visit each element once. Comparing the two, the brute force approach has a time complexity of O of n squared because of those nested loops. The optimized version brings that down to O of n, meaning it scales linearly with the input size. Both use O of one space since we're only storing a few integer variables regardless of the array size. And that's how you move from a quadratic solution to a linear one. The key takeaway here is tracking the global minimum as you traverse the array. If you found this helpful, hit the like button and I'll see you in the next one.